Hello, it's me again, Tanya Chew. In this video, I am going to talk about how to score your IGCSE Physics paper 4 or short structure questions paper. So every student knows that paper 4 is no joke because it contributes a lot of marks to the whole IGCSE paper to ensure that your A star in IGCSE Physics is secured. But in this video, I'm not just going to give you the tips. I am also going to discuss some of the past papers and applying the tips that I'll be giving you to ensure that you know how to make use of the tips that I'll be giving you in applying to your own paper form. So please stay tuned until the end of the video. Tips number 1. It is about the understanding of the instruction words given. Let me give you some examples of the instruction words, such as state, compare, describe, explain, etc. So you have to make sure that you know each and every instruction words, the command that is given by these instruction words, what they want you to write in your paper form. So I'm going to discuss all these instruction words one by one. First, compare. When you see the word compare, it means that they will give you, from the question itself, it will give you two or more physical quantities. Like you look at the word itself, when I ask you to compare between this person, these students, and the other students, what would you look at these two students? Of course, you will look at their similarities and then compare, okay, and their differences. Then only you make your comparison. Oh, this student is taller than the other student. That is what we call comparison. So when two or more physical quantities are given, all you need to do is, first of all, look at their similarities and then the differences. Then only you make your comparison. For example, compare the wavelength of sound in air and in water. First, 1 mark will be given. Before you compare, you need to have a little bit of knowledge about the speed of sound in air and the speed of sound in water. This is speed of sound in air. The range of speed of sound in air is about 330 meter per second to 340 meter per second, whereas the speed of sound in water is about 1,500 meter per second to 2,000 meter per second. So what to do with the speed and the wavelength? Now apply the equation of wave. Have you ever seen this equation before? V equals F lambda. V represents the speed of the sound. Lambda represents the wavelength. F represents the frequency. Since we are talking about the same sound, frequency of this sound is constant. So when the frequency is constant, all you need to do compare is between the speed and the wavelength. When the speed is directly proportional to the wavelength, that also means that when the speed is larger, the wavelength is also longer. So since the speed of water is larger as compared to the speed of sound in air, I would say that the wavelength of the sound in water is larger than the wavelength of sound in air. That is how you're supposed to compare. Now, second term, define. Define is a statement or the real meaning of a term. Before we define something, you have to bear in mind is that definition is actually for some physical quantities which have been proven experimentally correct. For example, let me give you about humans. We are all human. You are human. I am human. So what's the difference between us? Maybe you can say that you're female, I'm male, or but what about female and females? There are so many females, there are so many males. How are we going to compare? How are we going to define each other? So we look almost the same. Could be so we are female, not almost the same. I'm sorry. But we are female. So how to define you and how to define me is the name given by our parent. Oh, you're given this name. That is specifically for you only because your parents gave you the name. So that name is going to define you. Same goes to physical quantity. Example, define impulse in terms of force and time. You know that there are two equations of impulse. Impulse is equal to, let me write it down first. Impulse is equal to change in momentum, final momentum minus initial momentum, or product of force and time. Since they ask you to define impulse in terms of force and time, how do you define it? Just write impulse is equal to product of force and time. Or if you don't like to write in this way, you can also write it as impulse equals force times time. That's it. 1 mark is yours. The next one, define pressure. There's so many equations related to pressure. Pressure of fluid is equal to rho GH. Pressure, okay, this is density of the fluid. This is the gravitational acceleration. This is the height measured from the ground if you're talking about a gas. When you look at the word define, there's only one definition, like what I say. The definition of pressure is force per unit area. But if you write the definition of pressure as rho GH, you won't gain any mark because that's the definition. There's only one definition. And remember this, there's only one definition in every physics term. So the other one, P equal to rho GH, that is another expression to express your pressure in fluid. And it is not valid to solid. Now, state. State, that means you give the answer directly. No further ideas needed. You don't have to make some explanation. State whether you want to go or don't want to go. Yes or no. That's the answer they want. I don't want to know, oh, I'm not going because you don't give me because this and that, because I don't want to hear that. State just one answer, yes or no, no change, increase, decrease. That is what we call state. Look at this example. State the name given to negative acceleration. Very simple. It is called deceleration. That's simple. Now, the next one. Describe. Okay, so describe is like telling the whole story. One day I go to the school, I see this person, blah, 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 blah. That is how you describe. And you need to talk about the details. At this time, I was in this school compound doing whatever stuff that you need to talk about. And talk about the properties. Talk about what you observe, what you can see. If diagram or figure is not being given, just look at the statement given. So describe based on the statement given, what you understand from the statement, or if a figure is being given, even better, what can you see from the figure given? And please do not ever talk about why it is happening. I see that the pressure is increasing. Don't tell me why the pressure is increasing. Just talk about what you can see. That is called description. Example, describe in terms of motion and arrangement of the particles, the structures of solid and gases. First of all, I need to highlight this because it is about motion. Just focus on motion. Just focus on the arrangement of the particles and compare between the structure of solids and gases. That's all you need to do. Okay, let us see. For solid, the particles are well arranged in a very close manner because you definitely know that solid particles are very close to each other. And bear in mind, for solid, never ever use the word move, M-O-V-E, because solid particles can never move. They can only vibrate about their mean position or their fixed position. Vibration means you move a little bit to the left, you move a little bit to the right, you move a little bit upwards, you move a little bit downwards. That is what we call vibration. And you have to go back to your original position. Move, go back, move, go back. That is what we call vibration. Gas. Whereas for gas particles, they are very far apart from each other and the particles can move. When you talk about the gas particles can move in zigzag motion, random directions all the time. That is how you describe. And explain. Give me the explanation that I need. What is explanation? You need to give detailed statements. Give reason why you are doing this, why this is happening. That is what we call explanation. And link, if you can, link to any physics law. Hooke's law, for example, or any physics principle. Principle of conservation of momentum, for example. Let us look at some question here. Explain in terms of the momentum of the molecules why there is a pressure at the inner surface of the balloon. First of all, okay, I'm going to highlight the important terms here. Explanation is the word command, and I have to talk about the momentum of the molecules first, and then I have to link to the pressure. Okay, before that, okay, the end product, the end result is the pressure. So I need to know, pressure is related to force over surface area. I don't have to worry about the surface area because the balloon itself has a surface area. This is a balloon. Okay, these are the surface area of the balloon. Okay, this part, let me highlight this. Okay, these are all the surface area of the balloon. And inside the balloon, of course, there are air particles that are moving in random directions and they collide with themselves as well as the wall of the container most of the time. And you have to bear in mind that since the limited space that they have, because the balloon is not so big, since the limited space that these air particles have, therefore the collision is quite frequent. So they will collide. When you talk about the pressure, you have to link to the surface area of the balloon. You have to talk about the collision between the molecules and the inner surface of the balloon. So the balloon will collide with the inner wall of the balloon, the molecules, and then rebounds back. Now, due to rebounds, I use the word rebounds, keywords that. Rebounds meaning to say that you go towards the wall, you hit the wall, and then you come back with the same speed, because we make assumption here, the molecules, the collisions between molecules and the wall is perfectly elastic. I will give you more example. Okay, let's say this is a wall, inner wall of the balloon. So you just imagine I have one balloon, I have one molecule here. Just imagine one molecule only. So this molecule have a mass m and moving towards the wall of the balloon with the speed u. I'm talking about speed. This is u means initial speed. And due to collision is perfectly elastic, this molecule M will rebound back with the same speed, which is also u. If you want to find momentum, you have to understand momentum, the term momentum first. What is momentum? Momentum is defined as mass times velocity. I use the word velocity because it is related to direction. Oh, now I'm talking about direction. When it is related to direction, you look at this. Going towards the wall, one direction, rebounds back from the wall. It is the opposite direction. So you have to put positive to one direction and negative to the opposite direction in order for you to find momentum, the change in momentum. So change in momentum, I'm going to write it down. Go on. I'm going to use different color, purple maybe. Change in momentum. Bear in mind, change in momentum is always final momentum minus initial momentum. So this is what I call final momentum because molecule rebounds back with the same speed. I will put positive direction to my final velocity and negative to my initial velocity. So the mass of a balloon is m. So m positive u minus, because change means the difference. M negative u. Oh, I better write it here. M positive u minus, due to the difference in momentum, negative u here. Negative u here is due to the direction of the velocity, initial velocity. So this is mu, negative and negative becomes positive, mu. So the change in momentum is 2 mu. Could you see that? There is a change in momentum. So how am I going to relate momentum to force? Do you still recall Newton's second law? Newton's second law, I'm going to write it here. Newton's second law states that the force is equal to the rate of change of momentum. As long as you have the change in momentum divided by the time travel, right? Towards the wall of the balloon, you can find force. So force per unit area gives rise to pressure. So how are you going to explain this question here? First of all, I am talking about molecules collide with the inner surface of the balloon because pressure is due to the collision between the molecules and the inner surface of the balloon. And bear in mind, the collision must be perfectly elastic. So due to perfectly elastic collision, there is a change in momentum of the balloon, of the molecules, and rate of change of momentum that will give rise to force. Pressure is just equal to force per unit surface area or inner surface of the balloon. There you go. The next one is justify or justification. Justify your statement. So you have to give a statement with a solid proof. And normally when they ask you to justify something, they will give you a graph or a table. All you need to do is just to do a simple calculation to show the results like numbers or the relationship, whether it is valid or not. For example, Fig 7.4 shows a magnet 1 placed on position 1 and magnet 2 placed on position 2. State the direction of the force that the end pole of magnet 2. So when you talk about magnet 2, please only focus on magnet 2. This is the one. Exerts on the north pole of magnet 1. So north pole exert on the north pole. You know, north and north, like poles, they will repel. So north pole from a magnet 2 going out. Everybody knows that magnetic field must be coming out from the North Pole. So I say towards left. And justify your answer. Why do you say so? Okay, it is due to the magnetic field always flow out from North Pole. So show. Okay, you don't, most of the students when you're asked to show something, they don't have to draw hand. Nah, this is it. Normally, show question is related to proving some formula or maybe some calculations. You need to show you get this value. But you have to bear in mind as well, you need to write down the intermediate answer. What do I mean by intermediate answer? I will show you from the one of the past question. How about that? Let us look at the past question. So this is it. Fig 5.1 shows an electric heater used to heat a room. And the dimensions of the room are 4.5 meter times 6.1 meter times 2.4 meter. The density of the air is 1.2 kilogram per meter cube. Show that the mass of the air in the room is 79 kilogram. So how do you show that? When I see the word density here, first, I need to come up with the equation of density. I am going to show you right here. Density is defined as mass per volume. Mass, I have to find mass, so I do my cross multiplication. How about that? Mass is equal to density multiplied by volume. Density is given 1.2. So the mass must be in kilogram because density is in kilogram and the volume must be in meter cube. So don't worry, all the dimensions of the rooms are given in meter. So all you need to do is just to times 4.5 times 6.1 times 2.4. So after that, use your calculator. Give me a while, 1.2 times 4.5 times 6.1 times 2.4. And I got 79.056 kilogram. After I wrote that, then only I rounded off to 79 kilogram. This is what I call intermediate answer. Whenever you write down the numbers, you have to perform the calculation in your calculator. Of course, you don't have to show what is how you press your calculator, but you need to show the answer that you have gotten from your calculator. Remember that that's called intermediate answer. You cannot just write 1.2 multiplies by 4.5 multiplies by 6.1 multiplies by 2.4 equal to 79 kilogram. Unless your answer is exactly 79 kilogram. Else, you need to write the intermediate answer. Then only you round it off to 79 kilogram. That is what I call intermediate answer. It's very, very important. Now, tip number 2. Most of the students stated that I didn't gain full mark because my teacher said that I lost keywords. I didn't write down keywords. So what are keywords? Keywords are important physics terms. For example, you have to use the word like maybe pressure, maybe momentum, acceleration, velocity, speed, increase, decrease. You will lose mark if you don't include the keywords. Like when the car is moving faster, what is the term that we use? We use acceleration. If the car is slowing down, what is the term that we are using? We are using it as deceleration. Those are called keywords. Now, question number 1. Let me discuss this because terminal velocity seems to be very, very important in your paper form. Describe, not just describe what you can see, but also explain the motion of the ball. Motion, remember, motion is related to movement of the ball when it is released in air until it reaches terminal velocity. Now, 3 marks is being given right here. I am going to show you how to write this answer here in order for you to gain that 3 marks. First of all, I'm going to draw a diagram to make sure that you understand the whole situation. I draw the diagram here, and I'll do my explanation at the back of the next slide. So this is a very tall building. This is a ball. I'm going to put in some numbers so that you can understand the concept of terminal velocity. I would say, let's say, the weight of the ball is equals to 40 Newton. Bear in mind, and another thing that for you to take note is that air resistance increases as speed. I put arrow pointing upwards, meaning to say that that is increasing when the speed of ball increases. And also another important thing that you should know is that the weight of the ball in this case is constant because the ball is, after all, the experiment is being conducted on Earth. The ball is not being removed to other planets, right? Therefore, the gravitational acceleration is constant, mass of the ball is constant, weight of the ball is also constant. And another thing, let us start the process right now. At first, the ball has 0 initial velocity. That also means that the ball initially is at rest. So when the ball is at rest, the only force that acts on the ball is the weight of the ball, which is 40 Newton. Weight is always acting downwards because the gravity is always pulling the ball downwards towards the center of the Earth. Since the initial velocity is equal to 0, there's no air resistance acting on the ball because air resistance will only act when the ball is moving, when the ball has speed. Now, at this point, let's say, I'm going to put in some numbers so that you can see. The speed of the ball is 10 meters per second. And let us also say that before that, okay, let me write this down first. Initially, the ball is not moving. So the only force that acts on the ball is the weight of the ball, which gives the ball the resultant force, which is equal to 40 Newton. I put FR. FR represents resultant force. And let's say when the ball is moving, of course, when the ball moves, when the ball is falling downwards, the speed starts from minimum. So the speed, let's say, increases to 10 meters per second. So weight is still acting downwards, which is 40 Newton. But this time, because due to the speed of the ball, there will be another force acting on the ball, which is called air resistance. Since the speed of the ball is not so large, I would say that F air is not fair, it's not fair. So F air represents air resistance. The value of air resistance, I just put it in, let's say 10 Newton to make my calculation simpler. Now, because there are two forces acting on the ball, one is downwards, which is 40 Newton. The other one is upwards, which is 10 Newton. You know that force is a vector quantity. To find the resultant force, you need to consider one direction as positive. The opposite direction would take negative value. I will put negative to air resistance. Upwards is negative, downwards is positive. Therefore, my resultant force will be equal to 40 Newton minus 10 Newton, which is equal to 30 Newton. And at one point, you will see that Let's say at this point, speed is getting faster and faster. Let's say at this point, the speed of the ball is 40 meters per second. Okay, there are still two forces acting on the ball. Weight is constant, like what I mentioned earlier. But the air resistance increases as the speed of the ball is increasing. So air resistance increases to 40 Newton upwards. What happened to my resultant force? 40 Newton minus 40 Newton. Don't you think you get 0 Newton? When I get 0 Newton, it also means that my resultant force is equal to 0. When my resultant force is equal to 0, because resultant force is related to acceleration. No resultant force, no acceleration. So the ball will stop accelerating, and that point onward, the ball will fall with that velocity, 40 meters per second, until it reaches the ground. That velocity is called terminal velocity. Now, let me write down the answer in order for you to score that 3 marks. How are you supposed to write down the answer? First, split it, okay? Divided it into 3 stages. First, I state it as at the start of fall. I will assume that the speed of ball is 0. Air resistance. Or I don't want to talk about air resistance. Maybe I talk about, okay, the only force acts on ball is its weight. And I will say that I want you to see this screen again, this slide again. Could you see that at the start of the fall, resultant force is maximum, and it keeps on decreasing until 0. Same goes to acceleration. At the start of the fall, acceleration is maximum, which is equal to acceleration of free fall, which is 9.8 meters per second square. And it will keep on decreasing until it is equal to 0. Now, is its weight? Ball falls with maximum acceleration, which is equal, if you want to be more detailed, you can say 9.8 meters per second square, not a problem. And, okay, the second part, when the speed of the ball increases, air resistance increases. When the air resistance increases, what happens? Resultant force acting on ball decreases. Acceleration of ball decreases as well. See that? And then third stage, for the third mark, at one point, I don't know which point because the weight of the ball is not being given, so I would say at one point, speed of ball is maximum. Use the word, keyword is like maximum, minimum, right? Speed of the ball is maximum. Air resistance equals to weight of ball. Resultant force on ball is 0. Therefore, acceleration of ball is 0. The ball falls with terminal velocity. That is how the terminal velocity is being reached. That's all. Now, okay, if you want to know more about terminal velocity and the free fall, you can check out one of my YouTube video, which is this one on my YouTube channel. Thank you. The next one is about calculation, right? For calculation, don't have to worry. You look at the mark or the marks allocated. If they give you 1 mark or 2 mark, you can perform your calculation without writing any equation or any formula. But if 3 marks or more than 3 marks are given, then whenever you perform your calculation, please remember to write down the equation or the formula that you use. Let me give you some example. Wow, a microphone is in a recording studio, has a mass of 0.55 kilogram and a weight W. Calculate W. Look at the marks given. This is only 1 mark. So how do you calculate the weight? Whether you want to write down the equation that you are using, W equals mg, or you want to perform your calculation straight away, it doesn't matter. So you can write this as 0.55 times 9.8, because G now changed to 9.8. Remember that 0.55 times 9.8, give me a while. So it is 5.39 Newton. So whenever you write down your final answer in the space provided here, you need to bear this in mind as well. Before you write down your final answer, before you fill in the space given here, you need to make sure that your final answers are rounded off to minimum 2 significant figures, maximum 3 significant figures. So you can put 5.4 Newton or 5.39 Newton in order for you to get that 1 mark. And make sure that the unit must be correct as well in order for you to get that 1 mark, right? So the next question is about a spacecraft of mass 35 kilograms is traveling in a straight line at a velocity of 1,200 meters per second. Assume no external forces act on the spacecraft, thank goodness. Calculate the momentum of the spacecraft. You see, this is 2 marks given, but I would prefer to write down equation because I know which formula that I'm using. It is mass times velocity. 35 times 1200. Give me a while. 35 times 1200, and I got 42000. And the unit of momentum is kilogram meter per second. Just fill in the blank. Make sure that the unit must be correct as well in order for you to gain that full marks. And this one, electricity. Okay, let us look at the question over here. 1 mark and the other one is 4 mark. Okay, easier for me to show. A battery is made up of 8 cells in series. Each cell has an EMF of 1.5 volt. The battery is connected to one 8-ohm resistor for 40 minutes. Calculate the EMF of the battery. So each cell. This is a battery made of 8 cells. So 8 cells you combine together to give you that EMF of the battery. So since 8 cells, so I need to put 1.5 volt for one battery, one cell times 8, which is equal to 1.5 times 8, which is equal to 12 volts. So my answer for the first one is 12 volt. Very simple. Calculate the energy. Okay, let me draw the circuit so that you can see it clearer. So I will say that this is a battery, which is 12 volt, which is being connected to, okay, maybe I should draw a battery like this. Okay, give me a while. Okay, this is 12 volt. I draw only a few, yeah, whereas I'm supposed to draw 8. So this is a resistor, and this is 8 ohm. And you have to calculate the energy transfer from the battery in 40 minutes. Energy is equal to VIT. So in this case, because of 4 marks is given, so you have to write down the equation that you are using. 1 mark will be given to that. So I just want to look at this first, whether I have enough information. I am using VIT, yes. Do I have V? I don't have V. Do I have I? I don't have I. Do I have T? Time. Time for energy, because energy must be in joules. Time must be in seconds. So you have to change this time to second first. Let's see. 40 minutes. You want to change to second. You just times 60. So 2400 second. 40 times 60, 2400 second. Now the problem is I don't have V, I don't have I. Okay, let me recall. If I cannot recall any of the equation related to electrical energy, never mind. Recall Ohm's law. V equals IR. Is that okay? V, I have V, which is the EMF of the battery, but I don't have I. V I have EMF of the battery. So I is equal to V over R, and I sub into that equation, V over R times T. So I make some modification. I have V square over R times T. My energy is equal to V square because this is a battery. So V square is 12 square over R. R is the resistance of the resistor, which is 8, times the time, 2400. times 144 divided by 8. You are supposed to get 43200 joules. That's the answer. So if you want to know more about how to score, I also did some video on how to score your IGCSE Physics Paper 6. You can check out on my YouTube channel, and MCQ. So how do you score your MCQ question? I did give some example based on past questions. How do you score your MCQ question, paper 2? And how do you score your paper 5 and paper 6, the final boost? What are you supposed to bear in mind? What things that you should remember, yeah, in order for you to score full marks in your paper 5 or paper 6? And also, okay, how do I apply the 4 tips that I gave you in answering some of the paper 5 and paper 6 question? So please check out these on my YouTube channel, right? So I will see you again. This is the one that is important, graph plotting. So because your graph is very important in physics. So if your graph is not being drawn nicely, you will lose mark for the calculation part. You might not be getting the answer that is in the range. That is why plotting the graph is also very important. So please do check it out on this video, and I will see you in my next video. Thanks for watching. Bye.